Okay, here in 7.2, we're going to look at our cases that can have some ambiguity to them. And so the previous section, those were pretty straightforward. You're just looking at congruent triangles. But here we're looking at the case of side-side angle, which is actually not a congruent uh, theorem that holds. So what happens is that's why we call it the ambiguous case, because there's a couple different things that could happen. So in this example over here, so if you're given two sides and an angle, there's three things that could happen here. You could have a triangle with an obtuse angle, okay? Or what could happen is, see, this side length is the same right here. What could happen is it actually could flip out. And what happens is you have a larger angle up here, and then your angle B is smaller, okay? And then side B would be longer also. You could see right here. So that could happen. You could also just have a right triangle to where you only have one triangle. What can also happen is that you don't have any triangles. And so what could happen is, you're given a side, side, and then an angle. And what could happen is the side's too short to form, uh, to make a triangle with those three sides right there. So that's another case that can happen, is that um, it doesn't even form a triangle. So it is definitely a little abstract, but if you follow these conditions down here, this will kind of help you to determine what you're dealing with. Okay, so we're going to use law of sines, which that's pretty simple. It's just a ratio. And when you solve your law of sines, what happens is if you end up getting, oops, sine of your unknown angle is greater than 1, that's going to be impossible. So there's not going to be a triangle there. There doesn't exist a ratio for an angle of sine that's greater than 1. Okay? And so whenever that comes up, it'll be really obvious that, oh, well, that must be one of those cases where it does not even form a triangle. Okay, what else could happen is that if it equals 1, you should know that that's 90 degrees right there. So you're dealing with a right triangle, and that will automatically be one triangle that satisfies that condition. Now, here's where we have a little bit of our ambiguity right here, is that if it's somewhere between 0 and 1, you could either have one triangle or two triangles. So you're definitely going to have at least one. Okay. Now, this is where it gets a little tricky. Okay. So you have to look at this in terms of, we'll call them case one, case two. Okay. So case one, if sine of b equals k, then you'll go ahead and take the inverse of both sides and solve for angle b. Okay, and then if you know angle B, you can go ahead and find the other parts of the triangle. Now, there could be another case, though, and that would be where what we're going to do is we'll call this case 2. What you do is you take 180 and subtract it by the angle that you found from case 1. And as long as that new angle plus angle A is less than 180, then it's going to be possible for there to be a second triangle that exists with the given characteristics. Okay, so let me go up here real quick and kind of show you that in this picture again. So what happens is you might have angle. Sorry, let's see. Okay, so you might find angle B right here. This could be like B1 right here. And then when you subtract that from 180, that could actually make this B2 right there. Okay, and then what you could do is find your missing pieces from there. Um, and so you could actually have two distinct, unique triangles with the given characteristics of side-side angle. Okay, so let's try a couple of these examples, and I already have the outcomes listed here. So what happens if the triangle is not possible? Well, that whenever that happens, like I said, it's going to happen real quick. You'll realize it real quick. So right here we have angle C is 75 degrees in 30 minutes, which, 30 minutes is half 30 minutes, 60 minutes an hour, so 30 minutes. So that's the same thing as 75.5 degrees. If you want to just convert that to degrees, you can. So I just did 30 divided by 60, gave me that 0.5 right there. Okay, now we're given side A and side C. So we're going to set up one of our law of sines ratio. So you have to be given a side and an angle um, from the same uh, right here. So we have angle C and side C, so we can do our law of sines. So we're going to have, and it doesn't matter which one goes on top. So I'm going to put sine on top. It doesn't really matter. So sine of 75.5, and then on bottom we'll put the side that goes with that, which is going to be 13.2. And then we're going to set that equal to, and we're going to create a ratio here with side length A. And so we don't know what sine A is. So we'll put sine A on top all over 17.9. Okay, and then to solve this, we'll just multiply both sides by 17.9. Give myself a little bit more room. So multiply both sides by 17.9. So we're going to end up with sine of A equals 17.9 times sine of 75.5, and then all divided by 13.2. Okay, so all I did was isolate my sine of A. So then we'll go ahead and figure out what that is in my calculator. So let's see, 17.9 times sine of 75.5, close that, and then we're going to divide that by 13.2. So we get 1.31, so on. So let's see, sine of A equals 1.31, so on. And so if you tried to take the sine inverse of that, so if I do sine inverse of 1.3128, whatever, it's not really going to make a difference because it's going to come back with an error. Okay, error. So that's not even possible. So even if you're kind of unsure on what you're doing, once you get here, it's going to be pretty clear that that's not going to work for you. Okay, so that's our example of no triangle possible. So you do your law of sines, and you end up with sine of whatever your, angle A, B, C, whatever you're dealing with, and you have a value greater than 1. All right. Now here is an example where we could have one or two triangles. Okay, so once again, we do this the same way we just did the other one. So let's see, we're given angle A and side A. So we'll set up our ratio. Once again, it doesn't really matter. I could put sine on top or bottom. So 61.4 over 35.5, as long as you're consistent. And then that's equal to, then once again, I don't know the angle, so we'll put sine of B over 39.2. Okay. And so we'll multiply both sides by 39.2 like I did on the other one. So I'm going to try to just fit this all up here. Sine of B equals 39.2 times sine of 61.4 all over 35 point, oops, a little messy there, 35.5. Grab my calculator. So let's see, 39.2 times sine of 61, oops, 61.4, and then we'll go ahead and divide that by 35.5. Okay, so we get 0.9695. Let's just round it to that. So sine of B equals 0.9695. So we'll take the sine inverse of that so we can get that angle. So, or, yes, sine. So sine inverse of 0.9695. And we'll, they rounded, let's see, they rounded one decimal place. We'll do the same. So we'll round that to 75.8. So 75.8 degrees. Okay. Uh, okay, so that's going to be our case one. Okay, so we'll go ahead and label that case one. Okay, so what's going on is these will never change. These will never change. We're always going to use those three parts. But now that I know angle B, I can figure out angle C. And so that's what we'll do here. Okay, so for case one, we know that angle B is approximately 75.8 degrees. Okay, so if we want to figure out angle C, that's going to be 180 minus the two known angles, which would be 61.4 and then 75.8. And so let's go ahead and put that in our calculator. Okay, so 180 minus 61.4 minus 75.8. So we get 42.8. So angle C is about 42.8 degrees. Okay, so then the only thing we're missing now is side C. Okay, so what I'm going to do here is I actually want to go ahead and use the ratio I already started with up here. Grab this. So I'm going to use this ratio I've already started with. I'm going to paste it. Oops. Okay, I paused the video there for a minute just to kind of clean things up. So what I did here was I took a copy of my law of sines I was using earlier. I might as well, I already have it, so I'm taking this down here, but instead of dealing with angle B and side B, now we'll use angle C and solve for side C. So over here, we'll go ahead, let's see, so we're going to have uh, sine of, now this time I'm going to put in 42.8 since I already know it. And then we're going to divide it by side C, which I don't know. Okay, so the algebra here, what we're going to do is uh, basically we're going to cross multiply and divide. So I'm going to multiply this together, and then divide by sine of 61.4. So what's going to happen here is I'm going to end up getting C equals, and then so that 35.5 gets multiplied to the sine of 42.8. And then see, side is getting multiplied by sine of 61.4. So I'm going to divide that on both sides. So now that gets divided by sine of 61.4. Okay, so hopefully you see all the algebra that's occurring there. And so now it's time to put this in the calculator. So we'll clear that out. So let's see, 35.5 times sine of 42.8, close the parentheses, divide by sine of 61.4, close that, enter, there we go. And we can round, I'm going to round two decimal places. So let's see, 27.47. 27.47. Okay, so that would be case one. So what's going on here is we found, I guess that'd be centimeters. So, and they did one decimal place, and that's fine. Um, so we found the third side, and we found the two angles. We found angle B and C that could create the triangle with the given conditions. Okay. Now, it's possible though, what's going on here is whenever you're solving for an angle with your law of sines, it's always going to give you your angle between 0 and 90 degrees. So what if my angle B is actually obtuse and I just don't know it, right? And so that's where our case 2 comes in, okay? Um, so let's go ahead and try case 2. And there may be or there may not be a case 2. You just have to try. And it will be pretty obvious whether there is or isn't as you get started. So let's see, I'm going to block this off. Okay, so if we're going to have a case, oops, we're going to have case 2 possibly. Okay, so what we're going to do here is my angle B this time, we'll call this B sub 2 so we don't get confused with the one up above, okay? What you would do is all you do is you take 180 and you subtract 75.8 from it, okay? And that should leave us with what, 104.2, okay? And so we still don't really know whether this works or not. So what we need to do is I need to look at the given conditions and we'll figure that out. So I did make a copy of the given conditions. We grab them. I knew I was going to need them, so oops. Here we go. Okay, so here, oops. Here were the original conditions that were given. So let's see if I can shrink this down. There we go. And put that right there. Okay, so those were the original conditions right there. And so in this case, we need to figure out what would my angle C be. So angle C, we'll call it sub 2 for case 2, would be equal to 180 minus the two known angles. So we know angle A, which was 61.4, and then now we're in case 2, we're looking at it possibly being that angle B would be 104.2. So we'll go ahead and subtract out 104.2. And I'll use my calculator to make sure I don't make any mistakes here. So 180 minus 61.4 and then minus 104.2. That gives us 14.4 degrees. So angle C2 would be 14.4 degrees. So 14.4 degrees. Okay. So what I have so far in my case 2 is I have all my angles now. So with the given conditions with angle A, side A, and side B, it'd be possible that my angle B would be 104.2 and my angle C would be 14.4. So basically at this point, I know there definitely is the possibility of two cases. Okay, so I need to go ahead and figure out side C. Okay, so once again, what I'm going to do is I'm going to do the law of sines again. So we'll do sine of, let's see, 61.4 over 35.5 equals, and now we're dealing with C again. So I'm going to do sine of 14.4 over side C, which I don't know, right, for my second case. So what we'll do here is do our cross multiplication and dividing. So we'll end up with C equals 35.5 times sine of 14.4 all over sine of 61.4. So I'll need to put all that in the calculator. So let's see, 35.5 times sine of 14.4, and then we'll go ahead and divide by sine of 61.4, and so we get 10 point, basically we could just run that to 10.1. So C2, side C2 for case 2 would be 10.1 centimeters. And so those are your two possible cases here. So we figured out angle BC and then side C2 with with these possible parameters that were given to us. Okay, let's try one more example. There we go. Okay, so once again, we could either have one or two triangles. Probably we're gonna get just oops, we'll probably just get one triangle here. But let's go ahead and try it. So this time the conditions that are given, so we're given angle B, side B, and side A. So once again, we'll do law of sines to figure out our angle A, and then we're gonna test that there could be two possible triangles, and we'll find um, all the angles and sides that go with that. Okay, so here we go. So sine of 68.7 over 25.4 equals sine of A, we don't know, over 19.6. Okay, so the algebra here is pretty simple. So we're going to get sine of A equals 19.6 times sine of 68.7, all divided by 25.4. All right, so we'll go ahead and put this in the calculator. Clear that out. So let's see, 19.6 sine of 68.7, close it, divided by 25.4. Oops, what did I do there? Okay, so we get 0.7189, so on, and then you got to take the sine inverse of that. So we'll take the sine inverse of 0.7189, probably four decimal places is pretty good. So we're going to get, okay, 45 point, they gave it to us rounded to the nearest tenth. So that would actually round that up to 46 degrees. So that's nice. That'll make life a little bit easier. So we're getting that angle A is 46 degrees. Okay, so that's what we're going to use for case one. Okay, so for case one, okay, um, we figured out that angle A, and you can call it A sub 1 if you want. I didn't do that on the previous one, but we can do that, is 46 degrees. Now what we have to do is figure out angle C, and then go ahead and solve for it. We definitely have at least one triangle, okay? So let me make that clear. We definitely at least have one, and so we're going to go ahead and finish finding all the sides and angles of that first one. So, oops, jumping around on me. Okay, so, okay. Hopefully it doesn't do that again. Okay, so we need to find angle C1. So we know that a triangle is 180 degrees. We know two of the angles. We know angle A is 46 degrees. And we know that angle B, which was given, is 68.7. So let's go ahead and put that in here real quick. So let's see, 180 minus 46 minus 68.7. So we're going to get 65.3. So 65.3 degrees. Okay, so now for this first case, we know everything except for angle C. So what we'll do here is we'll set up a law of sines ratio and solve for that. And then we'll look at if there's a possibility of a second triangle with the given conditions. So let's see, sine of 68.7 over 25.4 equals, and then sine of 65.3 over, and then we don't know. So capital C for side length. Um, so we'll do some of our algebra here. So we should end up with side length C for case 1 is 25.4 times sine of 65.3 all over sine of 68.7. All right, so we'll grab the calculator. So let's see, 25.4 times sine of 65.3 divided by sine of 68.7. And let's see, we get 24. We can just round that one decimal place, so 24.8. Okay, so now we've figured out all the conditions for the given triangle. Now, what if, once again, like I said, whenever you're doing law of sines or taking the sine of anything, the angle is going to be between 0 and 90, okay? So what if it's possible that this was actually an obtuse angle? And so that's where we got to look at case possibility of having a second case here. So we'll call this case 2. And so what would happen here in case 2 is that angle A, we'll call it A sub 2, would be 180 minus 46, which would equal, let's see, 134 degrees, okay? Okay, so I went and copy and pasted the initial conditions. So this is our initial parameters that were given to us. And so we're looking, what's the possibility that maybe our angle is actually obtuse? And so what's going to happen here is we know angle B, side A. So now we got to look at side C in our second case. And so that would be equal to 180 minus the given angles that we know. Well, we know 134, and then we know that angle B, which never changes, was 68.7. So we'll go ahead and stick this in the calculator, and what you're going to see is it's not going to work. So let's see, 180 minus 134 minus 68.7. And so the problem here is we're getting that our angle C would have to be negative to meet the conditions, and so that's not possible. So you just don't really worry about it. There isn't a second case. And so with the given conditions, this is the only possible triangle that you can come up with. I hope this helps you out.